All right, let's go ahead with lesson 9.3 in your book, page 489, factoring trinomials in the form of x squared plus bx plus c. All right, well, first of all, let's review just multiplication again, and let's notice some things as we go. Let's say I have x plus 2 times x plus 3. I use my arrows and I multiply it out, and I get that x squared from the first terms. The outer terms are x3x, the inner terms are 2x, and the last term is 6. I combine those. I notice that the x's are like terms, so I really combine them. X squared is plus 3 plus 2x, okay, which gives me x squared plus 5x plus 6. Now let's take a look at x, just the factoring using variables instead of numbers. If I have x plus n times x plus n, I really just multiply that out. I get x squared from my first terms. My inner two terms, or my inner term and my outer term added together are n plus m times x. And the final term, the last term, is always m times n. Okay? So if you were to look at this in the form of x squared plus bx plus c, you'll notice that b would take the place of n plus m, or m plus n, here, and c takes the place of m times n. So since you know that's the pattern, we then now can start building some equations. So let's take a look at it here. Okay? Let's look at it very simply, restate it. X squared plus bx plus c is equal to x plus m times x plus n if m plus n is equal to b, the coefficient of the middle term, and m times n is equal to c, the coefficient, or the last term. Now let's look at this as an example. We use the example we used up above. X squared plus 5x plus 6 is equal to x plus 2, x times x plus 3. Well, let's take a look. Are our m and our n values, 2 and 3, are they going to be, when added up, do they equal our b value, which is 5? Well, 2 plus 3 equals 5. b is 5. That is correct. How about when I take m and n, 2 times 3 equals 6. Is that equal to c? Come over here, and yes, it is, c. So that's just a quick way of looking at it. And that's the pattern we're going to follow. We're going to look for an addition of two numbers that add up to the middle term but multiply to the third term, coefficient of the middle term. Okay? We have example 1. Example 1, what happens in the example 1 when I have the following? I have a equation or expression in this format: x squared plus bx plus c. And then in this case, I want to know that b and c are both positive. When they're both positive answers, b is positive and c is positive, what do we do? Well, how do we factor them? Well, let's just use an example. And example number 1 is this: x squared plus 6x plus 8. Well, I'm going to show you how to do it. You're going to, when multiplied together, two numbers that equal 8, and then add up to that. And how do you do that? Well, we're going to write the third number, the c value, in a factor table. But I'm going to add in it a third column, which I'm going to call the summation table, or column, or the plus column. So now I'm going to do my factors. Well, what is my factors of 8? Well, 1 and 8 equals 8. 1 times 8 equals 8. If 1 times 8 equals 8, well, what do they add up to? Well, they add up to 9. Is that number the b value, or the coefficient of the x, the second term? No, it isn't. So let's go on. Let's say 2 and 4. 2 and 4 added together give me 6. Is 6 the coefficient of that? Yes, it is. So that is the correct pair of numbers that I want to use. And when I say that, find that correct pair, I can then just say that this is factored out to x plus 2 and x plus 4. And that is the factoring of that problem. So, okay, let's restart here with number 2. Example number 2, we'll get x squared plus bx plus c, where b is a negative number and c is a positive number. Here's our example. X squared minus 10x plus 16. So b is a negative 10 and c is a positive 16. So we're going to make our little chart, our little factoring table where we want a positive 16. But since we know the addition of those two numbers have to add up to a negative number, and they both have to multiply to be a positive number, we're both going to be negative numbers. So we're going to start with negative 1 and negative 16. When multiplied together, that gives me positive 16. Added together gives me negative 17. So that's not the pair I'm looking for. Okay? So let's try negative 2 and negative 8. Well, negative 2 and negative 8, when added together, give me negative 10. Uh-oh, there it is. Negative 10, negative 10. So that tells me that 2 and 8 are negative, are my two numbers. So this is equal to x minus 2 times x minus 8. Okay, example number 3, we got x squared plus bx plus c again, but this time we're worried about when b is positive and c is negative. So our example here is x squared plus x minus 12. So b being not, there's no coefficient there, it really means there's a 1 there. So b is a positive 1 and c is a negative 12. Well, when I make my chart here, I know that I want to multiply up two numbers that equal negative 12, and when they add together, they want to add to a positive 1. All right. Well, when I multiply two numbers together to negative 12, I got negative 1 and 12. They add together to be 11. That's not what I'm looking for, so let's try 1 and negative 12. That's negative 11 when they add together. That's still not what I'm looking for. Let's try negative 2 and 6. Negative 2 times 6 added together gives me positive 4. That's not what I'm looking for. So let's try 2 and negative 6. That gives me negative 4. That's not 1, the 1 I'm looking for. Alright, so let's continue on. Let's try negative 3 and 4. Negative 3 and 4 adds up to be positive 1. Well, that is what I'm looking for. There's my positive 1. Even though it's not there, that's really a 1. So that matches. So this is my two factors. Numbers that go into my factors. X minus 3 and x plus 4. So see the negative 3 and the 4, negative 3 and the 4. And that is my factored answer. Now let's look at example 4. In example 4, once again, we're in the form, equation in the form of x plus bx plus c. And in this case, we're worried about b being a negative and c being a positive. Okay? So in this case, since hold on. That is not what we're worried about.